Hello, everyone, and welcome back to my online teaching platform. Still on application of differentiation in relation to tangent and normal to a given curve. So this is our second question. The tangent to the curve y is equal to x cubed minus x squared plus 1 at q. So the q here means that there's a point over there. So the point is q. Passes through the point. So the first point has coordinate as 1 and -3, and the second point has coordinate as 3 and 13. We have to find a possible coordinate of Q. All right. So let us represent our diagram. Let us represent our curve and our tangent with a diagram. All right. So let us assume that we have our curve here, okay, and we have a tangent to that particular curve. Okay, so that's what we are coming to do now. So okay, so let us look at the diagram here. So if this is our curve to be y is equal to f of x, all right, and there's a tangent to the curve. Let us assume the tangent to the curve is at this point. So this is where the tangent touches or the straight line touches the curve. That is why we call it a tangent. This is our tangent since it touches the curve at only one point. And they are saying that the point is q. Okay, the point is q. So we have the tangent to the curve y is equal to x cubed minus x squared plus 1 at point q. So this is where the line touches the curve. All right, so we have it as q, but we don't know the coordinates. So we can put a, b as the coordinate of point q. All right, now they are saying that the tangent passing through 2 points, and the first point is having a coordinate of +1 and -3. All right, so you can name one of them here to be your +1 against -3. All right, so these are the points. So it means these points are on the tangent since the tangent passes through this point. So you indicate the point on the tangent. So you can name them at point A and point what? B. So our B, you can put 3 against 13 here. So these are the points through which your tangent is passing. All right. Now we have to find the coordinate of point Q. Now, anytime we have a tangent to a curve, we learn that the gradient of a tangent to a given curve is the same as the gradient of the curve. So let us find the gradient of the tangent first. Since we have 2 points on the tangent, we are going to use the gradient formula, which is change in y over change in x. So that's what we are going to do. So our gradient, which is m, so gradient of the tangent, so our right tangent here, will be equal to y2 minus y1 divided by x2 minus what? x1. All right. So let us see what we'll be getting as the gradient of the tangent. So we have the coordinate to be 1. That's the coordinate of the first point to be 1 against -3, and the coordinate of the second point to be 3 against 13. So these are the points on the tangent because the tangent passes through them. So we are going to use them to find the gradient of the tangent. So we are going to get our m to be equal to y2. You can name any of them as your y2. So I will name my first coordinate of the first point to be my x1. So automatically the second one becomes my y2. Sorry, my y1. X1 goes with y1. So y1. Then the next one becomes my x2. Then automatically the corresponding y value becomes y2. All right. You can equally interchange. So somebody can name the x1 as x2. So when you come to the other side, it's going to be x1. So the moment you name the first number, let's say you name the one here as your x2, the corresponding y coordinate should be your y2, and you are still going to get the same answer. All right. So my y2 here is 13. All right. Minus y1, which is negative 3, divided by x2 minus x1, which is 3 minus 1. Let us see what we're getting. So we have our gradient to be we have 13 minus negative 3, and that will give us 16. Divided by 3 minus 1 will give us 2. And in all, we are going to get 16 divided by 8, and that gives us a gradient of 8. All right. Now, we know that at the point of intersection, the gradient of the curve is always equal to the gradient of the tangent. Okay. So that is what we are going to apply now. So the gradient of the curve must be equal to the gradient of the tangent. So let us look at how best we can get the coordinate over here. Now, so we take our curve. Our curve is y is equal to x cubed minus x squared plus 1. All right. So we find the gradient of the curve as well, dy dx, and this will give us 3x squared minus 2x. All right. So this is the gradient of the curve. Okay. So this is the gradient of the curve. So now, since they have the same gradient, we are going to equate the gradient of the curve to the gradient of the tangent. So we say that dy dx is equal to the gradient of the tangent, which is the m. So you are going to get 3x squared minus 2x equal to 8. All right. And this will give us a quadratic equation. So we transpose the 8 to the left hand side. You have 3x squared minus 2x minus 8 will give us a result of 0. All right. Then we now need to factorize. Okay. But before you factorize the trinomials, the quadratic trinomials at the left, you have to get 4 terms out of the 3 terms. So you need to find the product of AC. Okay, the A is the coefficient of x squared, so which is 3 times the constant term, which is negative 8, so negative 8, and this will give us a result of negative 24. Okay, now we need to now find factors of negative 24 that when you multiply, you get negative 24. But when you add, you are going to get negative 2. All right, so let us look at how best we can get those factors. So you'll be using 6 and 4. All right, I think 6 and 4. So 1 will be negative. So negative 24. Two factors that when you multiply get negative 24 will be negative 6 and 4. All right, but when you add, you get this result. That is negative 2, the coefficient of the x. So we are going to get 3x squared. So in place of the coefficient of x, which is negative 2, we are going to now write negative 6x, then plus 4x. Because when you add 4x to negative 6x, you get back to negative 2x. Then minus our 8 equal to 0. Now you now factorize by grouping. So you put the first two terms in bracket, 3x squared minus 6, in one bracket nicely, then plus 4x minus 8 also in another bracket. So we identify the highest common factors of each of the brackets. So we identify the highest common factor of these two terms. The highest common factor is 3x. So 3x dividing 3x squared will give us x. 3x dividing 6x, negative 6x squared will give us negative 2. All right. Then plus the highest common factor here will be positive 4. Then you open bracket nicely. We divide through by 4. So you get here to be x and here to be negative 2. All right. Now you can see that the expressions in the bracket are the same. So we just repeat one of them. Then bring the factors outside together. 3x plus 4. Because the 4 here is positive. So in one bracket. Then we have another one to be x minus 2. All right. All equal to 0. So now we look for the point. We are looking for the x value at the point where the tangent of the curve is equal to the tangent of the gradient. Sorry, the tangent of the where the gradient of the tangent is the same as the gradient of the curve. Sorry, okay. So let us work on each of them. So we have 3x. We pick each of the expressions in the bracket. 3x plus 4, then equate it to 0. So we have 3x equal to negative 4. Then we are solving the linear equation. So we divide through by 3. We divide through by 3. And we get x to be equal to negative 4 divided by 3. Then we take the other part too, which is x minus 2 also equal to 0. Then you're going to get x to be equal to 2. All right. So we have two x values. So it means these are the values of x at where the tangent meets the given curve. All right. So these are the possible values of x for which the tangent meets the given curve. So this is what we are going to do. Okay. Now we need to now find their corresponding y value. So since they are points on the tangent and the curve, it means they must satisfy the given curve. Okay, so to get the corresponding y value, this is what you do. Means you bring back the curve. Y is equal to x cubed minus x squared plus 1. So you pick each of the values. So at x is equal to positive 2, then you plug in the value of x to be 2, then you get the corresponding y value. So x will be here exponent 3 minus 2 exponent 2 plus 1. So you are going to get it to be 8 minus 4 plus 1. And this will give us 8 minus 4 will give us 8 plus 1 will give us, 8 minus 4 will give us 4, plus 1 will give us 5. All right. So the point becomes 2 against 5. So the x coordinate is 2 and the y coordinate is 5. Now we take the other value too. At x is equal to negative 3 out of, the other x value is negative 4 out of 3. Okay, negative 4 out of 3. So you bring back the function y is equal to x cubed minus x squared plus 1. Okay, so we are going to plug in the x value. So y is equal to negative 4 out of 3 exponent 3 minus negative 4 out of 3 exponent 2 plus 1. All right. So we are now going to simplify this to get the final result. Okay. So when we take the first one, we have 4 exponent 3. So let us look at it. 4 exponent 3 means 4 times 4 times 4. So 4 times 4 is 16. So negative 4 times negative 4 is positive 16 times negative 4 again. So it's going to be negative, I'm going to get it as negative 64 divided by 3 also times itself 3 times. So 3 times 3 is 9 times 3 is 27. All right. Then minus, we have negative 4 squared, and that will give us 16, positive 16. Then we have 3 squared, that will give us 9. All right. Then plus 1. So we continue to find the y value, the second y value. So we are going to get, let us find the LCM. The LCM of y will be 27. All right. 27 divided itself, we are going to get 1 times 64. Negative 64 gives negative 64. Now, we have 9 also dividing 27 3 times. So we are going to multiply the numerator of 9 by 3. So 16 times 3 will give us 48. But we have negative, there's going to be negative 48. All right. Now the 1 here is the same as 1 divided by 1. So 1 dividing 27 will give us 27. Times the numerator of 1 will still be 27. All right. So y will be equal to, we have negative 64 minus 48 plus 27. And this will give us negative 85 divided by 27. All right. Let us see if we can simplify. So I think we cannot simplify further. So the corresponding y value of x equal to negative 4 out of 3 is negative 85 over 27. All right. Okay. So we should find, we are to find the possible coordinate of q. So we conclude that the possible coordinates of point q, that is q, are, so the first one we had it to be 2 and 5. That is 2. So we have 2, 5 as one of the coordinates. And the other one we had it to be negative 4 out of 3 against negative 85 out of 27. All right. So these are the possible coordinates of point Q. All right. Let me use 2 minutes to go through it again. Then I think we'll be okay with that. All right. We have a question that says that a tangent to the curve y is equal to x cubed minus 2x plus 1 at point Q. So that's what we have done by this particular one. So this is the tangent. The tangent is in green. So the line with color green is what we are considering as the tangent because it touches the curve at only one point. All right. But we need to find the possible values of the point Q. All right. We need to find a possible coordinate of point Q. So every point has x and y coordinate. When it comes to the xy plane, we have x. There should be x and y coordinate. Okay. Now we have the point y here. We have our curve also given as y to be equal to x cubed minus x squared plus 1. And the tangent touches the curve at this particular point. All right. Now you have 2 points that the tangent is passing through. There's another part of the question which is saying that the tangent passes through point with coordinate 1 and negative 3 and another point with coordinate 3 and 13. All right. So you have to indicate those points on the tangent. We need to indicate those points on the tangent. Now we also know that a tangent and a curve, a tangent to a given curve have the same gradient at where they touch each other or where they meet. And that is the point where we have the Q. Okay. So the best thing to do is to find the gradient of the tangent and equate it to the gradient of the curve. All right, since they are equal. So we use the gradient formula, which is change in y over change in x, because we have 2 points on the tangent. And we use it to get the value of the gradient to be positive 8. All right. Now, since the tangent touches the curve at point Q, it implies that the tangent must have the same gradient as the the tangent must have the same gradient as the curve at the given point, which is the point Q. So we need to find the gradient of the curve as well and equate it to the gradient of the tangent, because at that particular point the gradients are equal. All right. So we differentiated the given curve to obtain the gradient function, which is 3x squared minus 2x. At the point where they meet, their gradients must be equal. So the gradient of the curve, the gradient of the curve, which is 3x squared minus 2x, must be equal to the gradient of the tangent, all right, at the given point, the point Q. Now we work on this equation and we had the values of x at that particular point to be, we had them to be positive 2 and negative 4 out of 3. All right. So when you are able to get the x coordinate at that particular point, it means you need to find the corresponding y coordinate. How do you get the corresponding y coordinate? You could say that the point is on the curve. So to get the corresponding y coordinate, you just plug in the y values into the given function, and you are going to generate their corresponding coordinates. So when you plug in 2, when you plug in 2 into the original function, you have it as 2 exponent 3 minus 2 exponent 2 plus 1, and we had the answer to be positive 5. So you pair the two coordinate to get a point. So one of the possible coordinates of point Q are 2 against 5. Then you pick the second x value at the point where the gradients are equal, which is this one. You also plug in this value. You are going to plug in this value into the original function to get its corresponding y value, and you have done that to obtain this value. So you are going to pair them, negative 4 out of 3 against negative 85 out of 27. All right. So these are the possible coordinates of point Q where the tangent touches the curve. Thank you for watching. Please do not forget to subscribe to my YouTube channel, which is Math with Ebefa. If you have more